Now, what requires us to use the chain rule? Besides me and the book. Who was saying something? Ryan, hi there. What kind? Yeah, it says right there on the screen, doesn't it? Composite functions. So now the next thing then is, what is a composite function? Some of you, when I looked at the test, I have some people I need to talk to a little more detail about this past test, and some of the things that came out was, as much as I've tried, you still haven't quite got the hang of a function having an input and an output. And for this, it would be, it's imperative that we understand that, because in a composite function, we have, the input, g of x is the output of function g, but it's the input of function f. And so when we have this input-output idea, then we get into this inside function and outside function. And again, the inside function resides inside another function. Another way I try to help you with that is to say, if I gave you a value, and I said, let's determine the value of y, and I say x is equal to 4, what's the first thing you would have to take care of? Don't everyone speak at once.
Substitute the 4.
Into, and do what with that?
Place the x with the 4.
And then do what?
Solve the parentheses.
And that would be add 4 plus 2. Yeah. You would have to first do what's inside the parentheses. That's our inside function. So if you can think of, my input into this entire function is 4, and my output of the first step, the composite function now, the first step is to say, what is 4 plus 2? That is our inside function. The last thing you do is to then take it to the negative 1/2 power. And so if we can get this inside-outside business going, just think about what you would do, order of operations. And that's going to help you, I hope, a lot. We looked then at, let me get down to a problem here. We had that rule. But I'm interested in a problem like this. GPR is just, I don't know if I made that up or if the book has it, but it's the general power rule. Don't get too hung up with things like that. Just look at that and say, is it a composite function? And I am just as happy, and I'm just as likely to call it the chain rule as a general power rule. Because even in the general power rule, we're chaining together derivatives. So here, the first thing I want to know is, do you see a composite function? You have to see the composite function first. And then you have to look at that. Now, by the way, I hope you're doing what I'm doing. I'm not looking beyond this right now. I don't care what's down here. My eyes are not going down there, so I'll just help you out by not letting you see that. But as this function, trying to decide what's the inside function and what's the outside function. Again, if I told you a value for t, where would you start? Would you start with the square root? No. You would start with finding out the value of the radicand, this piece right here. So 2t squared plus 5t plus 2 is the inside function. The outside function then says, take the result of that first step and take the square root of it. So the inside function is here, the outside function is here. When we find the derivative of this, do I start with the derivative of the inside or the outside? Well, I actually take both. I take both. That was kind of a trick question, I guess. But I take both of those. So this is the derivative of the outside function. And remember, I did something as silly as this on Thursday. I said, suppose that I had just something like smiley faces to the 1/2 power. What do you do with the derivative of that? Well, you take 1/2 smiley face and then subtract 1 from the exponent. I mean, it's just that silly sometimes. If you think about it, it's just that simple. Block that out. Don't even see it. Because the outside function says, I'm going to take the square root. 1/2 something to the negative 1/2. Now, what we have to do then is to then take the derivative of that inside function. And that inside function is 2t squared plus 5t plus 2. Now, it's going to become extremely important that we do one more thing. we have to be able to say what is, and I see I have an error on here. Well, I'm going to leave it and let's just talk through it, and we'll change it in just a moment. What's the derivative of the, what's the input variable of the derivative here? And what did I write? That was wrong. What should it be? Right here, t. Now, if you take your inspires, so let's do that right now. Let's see if I have one. There it is. What I want you to do is go home, pick up a new document. When you're doing homework, don't just keep using the same problem over and over again. You're adding more pages. At some point, get a new document. Let's go calculator. Let's go menu, calculus, and derivative. What's the first thing you have to put in when you use the Inspire to find a derivative? The variable, the input variable. You have to do that. Now I'm going to put in an X like I had in my mistake. And what was the rest of that? There it is. If I come over here and put in 2t squared plus 5t plus 2, I think I know what's going to happen. I think I know. I think what it's going to do is it's going to say, doesn't have an x in it. So it's going to pop it back out as a constant, does it? Yep, it does. It's treating that as if it's an unknown variable there, and it's saying the derivative is 0. Now let's go back up, pick that up, bring it back down, move the cursor over, and let's change the input to what it should be. Change that to a t. Now the derivative should be what? 4t squared plus 5? Does it happen? There it is. Okay? So if you follow what you have in the Inspire, it's going to help you out. Now, some of you, I noticed on the test, you did things like this. And I'm going to bring this down because it might have said evaluate this at the, where the input is 0. What are you saying when you evaluate that at the input of 0? When you put DDO, actually DD0, you're saying that 0 is what? Yeah. You're saying that 0 is an input and it's not. So now it's like, whoa, I don't know what to do with that because I can only use it with the variable, okay? And you got that message on it. If you think about what the notation is telling us, it really is there to help us, but we don't often know how to use it. So I'm trying to be real careful when we talk about this to make sure that I use some of the same notation all the time. So I'm going to, let's see here, take those away. Yeah. It's going to take it away a little bit at a time here, I guess. It's like little jack-o'-lanterns. Okay. What was this? 2t squared plus 5t? Okay, we'll do this. Plus 5t plus 2. Okay, let's see. Now that's going to go. Okay. So now, this is the other thing I can't emphasize enough. So what? What does this tell me? Can you write the sentence? Give it a try. Write it out. What does this represent? Write the sentence for you. Okay. One thing that you should write down is, this represents a what? Okay, let's back up a little bit. Even higher level than that, this represents a what? If I said f of x, you'd say, oh, that's a function, so what does this represent? It's a function. Okay, you're right in what you said before, because it's what I've been rehearsing with you, but this function gives as an output, now you can tell me what you wrote down. Gives as an output, what is that? The derivative is the slope of a line. Is it a special line? Yep, it's a tangent line. To what? Is there any special curve for this problem? Does this give us the slope of a line tangent to any special curve? Okay, tangent to S of t at what point? At any point. If I want a special point, what do I have to give you? A point, yeah, an input value. Okay. So anyways, again, a little bit of review thrown in with a little bit of reteaching of that composite function. Now hopefully you've worked enough of the homework that it's not quite as alien to you as it was last Tuesday, or Thursday rather. It's a little better. So you ready to move on to something else that uses this? Good. I like that enthusiasm. Okay. I'm going to start